Hello, my name is Sarah Fotovat and this is my final project for course Big Data in Johns Hopkins University. I'm trying to process New York yellow taxi data using Spark, AWS, and EMR. Here is a summary of what I'm going to cover in this Big Data project demo. First, we will review the project statement. In phase 1, I will install IntelliJ IDE in Windows and configure Spark in IntelliJ. Then I will download prepare New York taxi data in Windows environment, write Java code to analyze New York taxi data in Windows environment. Then I will test the Java code locally, create a jar file out of the Java code, and that's the end of the phase 1. Then in phase 2, I will set up EMR cluster in AWS, copy the jar file that was created in phase 1 from Windows to S3, copy the jar file from S3 to EMR environment, copy the New York taxi data to EMR environment, and then prepare and put the data in EMR Hadoop HDFS. Then I prepare the Spark deployment script to run the class file in AWS-EMR, run the Spark application, monitor data processing in EMR environment, and eventually provide the result. Here is the project statement. The goal of this project is in phase 1, write multiple Java classes to analyze yellow taxi trip record data in New York using Spark in IntelliJ in local mode. In phase 2, we will deploy the jar files that were produced in IntelliJ into AWS EMR, then load the data to AWS EMR, analyze the data with the jar file, and produce result. The data set that we will use is yellow taxi record data in New York 4 months before and after COVID-19. The yellow taxi trip records include fields capturing pickup and drop-off date and time, pickup and drop-off locations, trip distances, itemized fares, rate types, payment types, and driver-reported passenger counts. The URL for yellow taxi record data is listed below. Here is the continuation of the project statement. In this demo, we will cover it in detail. Here is the continuation of the project statement covering phase 2. The end goal of this project is providing a result set on different aspects of people writing yellow taxi before and after COVID. For example, volume comparison. Percentage of people writing yellow taxi before and after COVID in different New York taxi zones. Weekday rush hour analysis. What's the weekdays rush hour in different New York taxi zones based on yellow taxi data? Passenger count comparison. What's the percentage of passengers before and after COVID-19 in different New York taxi zone based on yellow taxi data? Or payment type comparison. What's the percentage of people paying by credit card versus cash before and after COVID-19 in different New York taxi zones based on yellow taxi data? Let's start phase 1, create Spark Java class in IntelliJ IDE. First, I downloaded IntelliJ and then installed it in Windows. In IntelliJ environment, I created a new Maven project. In mavenrepository.com, I searched for Spark core library, and here is the snippet that I'm going to use. I also found Spark SQL library, and here is the snippet that I'm going to use. I let Maven download Spark library and Spark SQL by adding XML snippet as property to Maven. Here is the pom.xml that has those two libraries as a dependency. Then I clicked on Maven icon and it downloaded all the required library. Then I created a new Java class. I create a sample Spark app Java class. All I am doing is I'm running it in local mode. I'm reading from a CSV file and I'm showing the result. Simulation of Hadoop environment is possible in Windows by downloading WinUtils from GitHub. This is where I installed WinUtils. I also needed to configure Hadoop Home in environment variables, and here is the value. Here is the result of Spark app.java that shows the content of a sample CSV file. When I started this project, I was researching on COVID data and people who got infected in Korea. And here is the result of that CSV file. In my Spark app class, I went one step further and I added an actual SQL query, which says, give me number of people and for every infection case. Here is the result of running that query. For every infection case, it shows the count. This shows that my local environment in IntelliJ is working. Here is how to write the result of the query in CSV file. Now that my Spark environment is ready in IntelliJ, I'm downloading the yellow taxi data in New York from October 2019 to June 2020, 4 months before and after start of COVID-19. I created two folders, one before COVID and one after COVID. And I copied all the data from October 2019 till January 2020 in before COVID folder and data from February 2020 till June 2020 into after COVID. Then I wrote 5 Java classes with the Spark SQL query in order to extract the following data from the CSV that I downloaded. In this Java class, I'm trying to find out yellow taxi ride count in different locations before and after COVID. This is a more sophisticated query showing the percentage of people riding yellow taxi before and after COVID-19 in different New York taxi zones. This is another class that shows weekdays rush hour in different New York taxi zones. Here is a more sophisticated Java class that shows the percentage of passengers before and after COVID in different New York taxi zone based on yellow taxi data. Here is the class that shows the percentage of people paying by credit card versus cash before and after COVID. Here is the continuation of payment type comparison class. Here is the result of running TestSparkQuery. Here is the result. And what is noticeable is that it's ran in local mode. Before creation of the jar file, the local mode has to be changed by commenting out this line. And instead, add this line, which is here. There are many different ways to create a jar file. I downloaded Maven and run MVN for compiling the Java code by providing the path to it. Here is where I downloaded Maven. Here is the command for creating the jar file. And this line shows that the build is successful. We are done with phase 1 of this project. Let's start phase 2 and see how the Spark application can be deployed in AWS EMR. In AWS services, I chose EMR and I created a cluster. Here is how I set up EMR cluster. I chose the Spark here. I also, for instance type, chose M4X large. Here is the setup EMR cluster summary that I created. This is the last EMR cluster that I created for this project. Then under S3 service in AWS, I created a S3 bucket with name Final Big Data bucket. Then I uploaded the jar file that has all my Java classes into my S3 bucket. Here is the list of files in S3 buckets. We can see that the jar file is uploaded successfully. Now the jar file is accessible in AWS, and here is the S3 URL. Then I set up PuTTY to access the EMR instance. And when I log into this instance, I use the user Hadoop and not a typical EC2 user that I use for my EC2 instances. In my EMR instance, I created a directory called Final Big Data Bucket. Then if this was the second time, I removed the previous jar file that I copied from S3. And then I made a new copy from AWS S3 copy. This is the URL where the new jar file exists into a local folder with the same name. In EMR instance, I created a directory called data. I downloaded all the yellow taxi data using a command wget, and here is the URL for different months. I did it September, October, November, December, January, February, March, April. Then I also downloaded the zone data. Again, wget, and here is the URL for the zone data. In this screen, it shows that the data file downloads are in progress. This one is 100% done. This one is 100% done, and the rest is in progress. Here is the screenshot of EMR instance showing that data file is getting downloaded from S3. This screen shows that all the data is downloaded in EMR screen. Now I created 3 folders before COVID, after COVID, and zone in HDFS with this directory structure. Here is the screenshot for creation of these folders in HDFS. Hadoop fs put command, copy all these CSV files one by one to HDFS. After files are copied into HDFS, we can look at the content of HDFS via the ls command, and we see that there are 2 directories here, after and before COVID. And if we look at the content of each of these folders in HDFS, we see that we have after COVID and before COVID data here. Then for each class inside the jar file, I created a shell. I have a passenger count comparison shell. I have weekday rush hour analysis shell. I have volume comparison shell and payment type comparison shell. As part of creation of deployment script to run a class in AWS EMR, I created these shells. Here is the content of volume comparison shell that deploy volume comparison class, which is embedded inside the jar file that we copied from S3. Here is the script content of payment type comparison shell, which is deploying the payment type comparison.class into Spark. Here is the content of passenger count comparison shell. It shows that the passenger count comparison class out of the Spark final jar gets deployed to Spark, and the output data, it's getting copied to passenger count comparison. Same way, the content of weekday rush hour analysis shell, it's here and it's deploying the weekday rush hour analysis class into Spark, and the output is in this folder. Then I ran each of these shells using the sh command. Here is the result of running volume comparison shell. Here shows that the volume comparison shell ran successfully. In order to monitor the data processing with EMR, click on EMR service in AWS, then click on EMR instance. Click on application user interface and then click on Yarn timeline server. It's shown on the next page. Here is application user interface, and here is the Yarn timeline server, and we are under EMR service. This page shows that the application with this application ID is successfully ran, and to get more detail you can click on this link and get more information about the application that you just ran. Here is how to create a log file from running this application and push it into another local file and then look at it. And one can search for exception in it. Here is the result of running passenger count comparison. It shows in different zone in New York, and it shows before and after COVID data. Here is the result of the query showing in different zone in New York, the percentage of people who paid cash before COVID, and then people who paid cash after COVID. Here is the result of running volume comparison in different zone in New York. Before COVID, number of ride was 171 in this particular zone, and after COVID is 48. So we see a 71% decrease. Here is the result of weekday rush hour analysis. It shows in Manhattan 1 a.m. on Sundays, it has the highest hourly average rides, and it decreases accordingly. Here is the screenshot showing the result on an EMR instance. What was covered in this Big Data project demo? I installed IntelliJ IDE in Windows and configured Spark in IntelliJ. I downloaded and prepared New York taxi data in Windows environment. I wrote Java codes to analyze New York taxi data in Windows environment. I tested the Java code locally and created the jar file out of the Java code. In phase 2, I set up the EMR cluster in AWS. I copied the jar file that was created in phase 1 from Windows to S3. I copied the jar file from S3 to AWS EMR environment. I also copied the New York taxi data to AWS EMR environment. I prepared and put the data in EMR Hadoop HDFS, prepared the Spark deployment script to run the class in AWS EMR, and finally I ran the Spark application. And I monitored the data processing in EMR while it was in progress and provided the result. I hope you enjoyed it.